Good morning, everyone. Thank you for coming. First academic session today, right? Yeah, I'm here to present our research on the performance evaluation and comparative analysis with MapLibre of large-scale 3D geospatial data. Anyway, this presentation outline here. Maybe you can get our slide. Okay. This QR code, you can get the slide available. So you may show our presentation files. So anyway, this presentation outline is here. There are 5 steps. Research background is so many big scale and large size geospatial 3D data. Another things next I will introduce to our methodology, the data source. We use the conversion workflow, the library. We tested and our performance evaluation metrics based on the core web vitals. Then we examine the result in detail, the overall performance comparisons, point cloud data, and the buildings, semantic data, display performance, right? And also, following that, we would discuss the implication of these findings, including key takeaways, technical consideration and practical selection guideline for different use cases. We will then highlight the contribution of this research, including our evaluation framework and real-world benchmarks. Finally, I will conclude with a summary of our achievement and outline future research directions before opening the floor to your questions. Anyway, as you know, the background, digital technology and advanced data utilization for digital twins era. Digital twins or virtual replica of urban environment show promise in urban development and also in Japanese case, disaster prevention and management, right? Despite technical challenges in generating requirement geospatial information, with advancements like the web graphic library, interactive 3D models and becoming more accessible, and particularly those displaying dynamic data such as human movement. This presentation, and also now we are writing the paper for ISBRS, offers a quantitative analysis of Japanese 3D city models in terms of volume and coverage. The qualitative comparison of over 4 use cases and associated geospatial applications. It is divided into 6 sections, each highlighting different project aspects and implications. Anyway, we are using the 3D city models built in Japanese government construction. Background of Project PLATEAU, as you know, in Japanese Ministry of Land, Infrastructure, Transport and Tourism since 5 years ago. Aims to modernize urban planning through the digital twins environment inspired by global projects such as the virtual Singapore and Helsinki and so on, some previous digital twins projects. This initiative, part of the broader national interest in smart cities and digital transformation, considering with the establishment new government city management. In its first year, in 2020, the project published 3D city models for maybe 18 million buildings in 200 cities in Japan, local government area, local government and local urbanized area, with data made openly and openly available. So anyway, accompanying this were the web viewer and maintenance manuals. So by about 3 years ago, data coverage includes the over 18 million building. So now we are showed the over the 200 cities with digital city models. So anyway, as you know, the Plateau view is openly used in the this Plateau page, so made by the Plateau sponsors, Eukarya, right? So and also the data coverage expansion, the open sourcing and openness, open sourcing via GitHub. You can get some information with GitHub pages. So anyway, this shows via the Plateau view in using the 3D city models in CityGML format. So anyway, you can access this QR code, so you can see the Plateau viewer. And also, for example, the full city building model and also the tsunami disaster model shows the overlay this website, right? So anyway, and also we are testing for not only Plateau 3D CityGML model, and also we can use the last format, 3D point cloud data. So our Japanese situation, the virtual Shizuoka, the full of the prefecture levels 3D point data and opened by CC BY license. So this Shizuoka's project is the details here. So anyway, importantly, we are selecting the one city full models. The Shizuoka's Numazu was selected as one of the only 56 cities project Plateau, and also the virtual Shizuoka's project, so creating both CityGML and 3D point cloud data. Right. So for our evaluation, we established two scale levels. The third mesh grid, which is 1 kilometer by 1 kilometer area, detailed analysis, and the second mesh means grid, which is 10 kilometer by 10 kilometer to test scalability with the largest datasets. The next slide, I showed the details figures. This dual scale approach allows us systematically analysis how data volume affects the display performance, right? So anyway, 3D point cloud data also shows the web interface in using the Cesium Ion in the prefecture Shizuoka's data, right? Also, you can show this QR code to show this display, this site. So anyway, our research has three preliminary objectives. First, we want to conduct quantitative performance comparison between CesiumJS and MapLibre GL JS across different data format and scales. So second, we aim to establish clear selection guideline. Developers need to know with technology to choose based on the specific use case, whether they are working the point cloud and building model and lightweight visualization displays. So third, we sought to create a reproductive and extensive evaluation framework. As web technology, you know, particularly with web GPU and the horizon, we need standardized methods that benchmark performance. So anyway, I already showed the case studies areas. So this map shows maybe full Numazu areas, right? So also we use the data sources here. So now we use the one of the 3D building models. Original format is the CesiumJS. And also total size and LOD, level of details, maybe 0 or 2 levels. And also we are converting 3D point cloud data, also shows the virtual Shizuoka. This point cloud data format is RAS and RAS format. Maybe unit size is 300 meters, 400 meters. The total size is very largest in this full Numazu cities area. So we are firstly data conversion and the workflow in displays web site. So point cloud data conversion from RAS to 3D tiles version 1.0, we use the five steps processes. And also the building models, we use the PLATEAU GIS converter for two different outputs. For 3D tiles 1.1, the newest 3D tiles formats, the converter produced the GLTF 2.0 compatible format directly from CesiumJS. This newer 1.1 3D tiles specification is important because it eliminates priority format and improves the interoperability. For anyway, we convert finally the CesiumJS to MVT vector types. So we are also using the PLATEAU GS converter with approaching zoom level settings to create lightweight 2D representations with building height informations. So any PLATEAU converter is openly used. So sorry to interface is only the Japanese language. However, you can try to the GitHub account, so you can show the PLATEAU GS converter the details. This is MIT license. The maybe file format is this list. So not only 3D tiles, MVT, also the Joe package and some the priority formats. So anyway, we test 5 distinct configurations across 2 major web mapping libraries. For CesiumJS, we evaluated 2 scenarios: point cloud data using 3D tiles 1.0 and becoming building models using 3D tiles 1.1. CesiumJS is well known for its native 3D support and optimization, global scale visualization. For MapLibre GL JS, we tested 3 scenarios. For point cloud data, we used MapLibre with DeckGL and LoadGL integrations. For building model in 3D tiles format, we used MapLibre with DeckGL. And for building model, we also testing MapLibre's native MVT format support. All tests were used the unified environment, the same viewpoint centered of Numazu station, the city center. This background map image, standard map, so provides the Japanese government GSI format, GSI base map data. Both scale levels we discussed either. So we also developed the custom two-screen comparison viewer that allow side-by-side performance analysis with synchronized viewpoints. This will provide invaluable for visual comparison during testing. So we are already published another previous research, Japan Map Compare with OpenStreetMap data. So now we are constructing to visualize the developed web interface side by side, point cloud data and some CTGML 3D tiles data. Maybe 3D map compare we named, right? So the performance evaluation method, we use the very simply method. So we choose the Google Chrome Lighthouse. So okay, okay. Core Web Vitals key 5 key metrics. This is right. So the result is here. Overall performance result. So best overall performance, the MapLibre JS and plus MVT. So very simply and very high speed display to performance, right? So anyway, point cloud data performance comparison, left side CesiumJS and right side MapLibre GL JS. So this shows a smaller is very high speed in display. So maybe 1 kilometer square is nothing. So maybe good performance. However, so big scale 10 kilometer square mesh, the very slow. Maybe TBT, very slow, the performance levels. So CesiumJS tile, 3D tiles 1.0, right? So, and also building models shows this result. So 3D models is less than the MapLibre GL JS and DeckGL, right? So anyway, MapLibre GL JS MVT performance this one. So speed index is very good quality and right size. So anyway, the key findings in summary is here. So first, lightweight data MVT with MapLibre GL JS is a clear champion, delivering the best overall performance with maybe FCP of 0.8 second and TBT of 0. 0 is a high performance display. So anyway, scale dependency, CesiumJS performance decreases significantly with data volume, MapLibre or consistent. So anyway, okay. Anyway, the future direction is here. So this study is first step assessment only the display performance. However, in GIS using the not only fast display, but also the processing and manipulate data layers and check some features. So we are we are now discussing the not only Google Chrome Lighthouse, but also the another testing performance tools. So I don't know the I don't know the another possibilities. Please discuss with another possibilities. So anyway, just end to my time. So thank you for Kia Ora. Thank you for my attention. Thank you.
Well, arigatou gozaimasu.
Arigatou gozaimasu. Thank you.
We've got time for 1 or 2 questions if anyone has something. Yes? Yes, hi.
Thank you. Can you hear me?
Yes.
Yeah, I can.
Sure.
It's fine.
You've got a connection.
Quick question on your GIS processing. The GIS processor you mentioned for 3D tiles, are you using, or the project has used the cesium ion for the processing, or what have you used for the processing of 3D tiles? Have you used the cesium ion?
Cesium ion.
Have you used it as part of that?
Sure.
Yes or no?
Yes.
Okay.
Sure.
Thanks.
Do we have any other questions? Oh, yes, hi.
Mine was going to be exactly the same, except I was going to ask for what were the backends? Were they identical, just file-based, or was it ion and something else from MapLibre?
Yeah, we are now so discuss with another things, another possibilities.
Okay, I'll take it to me.
Oh, that was really interesting. The people I spoke to before this talk, there was a lot of talk about 3D. And also I mentioned I'd been to Japan earlier this year and the Apple Maps were amazing. And they said it's because Japan's just so far ahead. So it's really, we're really fortunate to have you here today to tell us how this is, how you actually did all this. Yeah.
Thank you.
Cool, okay. Oh, well, thanks for that. And I'll invite down our next Percy.
Thank you.